How's it going, everybody, and welcome back to our Enterprise Practice Lab. In this video, we're going to be focusing on setting up Service Provider 3 and getting him all configured. We're going to do the OSPF adjacency like we did in ISP 2 and ISP 1. And then we're going to spend a little bit of time using the XRB and CSRs to set up a confederation-based network. If you've never dealt with confederations, it's a way of taking a very large service provider and breaking up into multiple smaller service providers to handle route control and things like that. Because when you have confederation peers and things like that, they treat each other, routers within inside the same confederation AS are treated like iBGP peers, and then any connections between confederation ASs are treated like eBGP peers. And it allows you to control routes and things like that that you normally wouldn't have if you had a full mesh of connections or whatever the case might be. I've never actually personally seen confederations used in a production network. Most of the clients that I work with are enterprise grade, so they don't have the scale to use confederations. Actually, I take that back. I dealt with confederations once, and it was, ironically, the person that put it in was studying for their CCIE. So it was one of those things where they threw it in there because they thought it made sense. It really wasn't a good design choice, but, nevertheless. So we're going to go through and do that. We're going to be using global ASN 3, and then we're going to have two different confederation ASNs, 1920 and 2930, which are going to be... we're going to be using the XR boxes are going to be appearing, and then the CSRs are going to be appearing, and then we'll peer to each other like this. And then we'll go through all of that, and once that's deployed, that'll probably be the end of that video, and then we'll flip over and get all of the in the next video we'll go through and get all the eBGP peerings done. Then we'll go through and get all of the customer peerings done, and then we'll be done setting up the ISP stuff. So without any further ado, let's go ahead and dive in to what we're going to do. Let me move over here. XR19, 20, 29, there we go. So XR19, go ahead and log in as Rob and as Cisco. Go to global config. Router OSPF 1, we're going to do area 0, or router ID is going to be 3.0.0.19, and then we're going to do area 0, interface gig 00000, and gig 1, and then interface loopback 0. We're going to go ahead and log adjacency changes, and I'm going to do a logging con debug and commit that config. So I'm going to go to 20 and do the exact same thing. I'm going to log into 20, go to global config, logging con debug, and then we're going to do router OSPF 1 log adjacency changes, area 0, interface gig 00000, gig 1, and then interface loopback 0, and commit that config. And then we're going to go to 29 and 30 and get them configured as well. So we're going to do router OSPF 1, router ID of 3.0.0.29. Oh, I forgot to do that on 20. But the cool thing is XRB19 should see it as 3.0.0.20. That's okay. I'm gonna let that one slide. We're gonna do log adjacency changes. Actually, it's already turned on, so we don't have to mess with that. I am gonna go to interface gig 1 through 2, interface range gig 1 through 2, and type in IP router IP OSPF 1 area 0, interface loopback 0, same thing. and I'll jump over to 30 and get him configured. That's a pretty short config considering the IGP isn't doing a whole lot. And then we're going to do router OSPF 1, router ID of 3.0.0.30, and then interface range gig 1 through 2, IP OSPF 1 area 0, interface loopback 0, just like that. So now that that's done, we should start forming adjacencies with all these other guys, and then I'll go through and 30 should come up here momentarily. So if we do show IP OSPF neighbor, and if we do show IP route, we should see routing coming across. 30 should be just about there. Make sure that my interfaces are up. OSPF takes such a long time to come online. There it goes. I'm just impatient. So we should have 29 and we should have 20. Why is that not coming online? Do show IP OSPF neighbor. Gig 1 show 2030. Let's XRB 20. Do show IP interface brief. Gig 1 2930. Oh, I had the wrong IP address on gig 1. That's my fault. So do show run interface gig 00000/1. Yep. So interface gig 0000001. IP address here will be 3.20.30.20/24. And we're going to go ahead and commit that. So that should change the config, and I should form an adjacency then. There we go. That's why. I was like, why is that not forming an adjacency? Do show IP OSPF neighbor. There we go. Do show IP route. Excellent. So we have it set up the way we want it to. So we got at least IGP is squared away and everything is good to go. The next thing I want to do is I'm going to start on CSRs to get this process started. So we're going to use 2930. So I'm going to type in router BGP, and what you do here is you use the when you set it up. So when you set it up, when you do router BGP 3, right? You come underneath here, and then you have BGP Confederation, and then you have identifier, and then you have the connection that you want to have. So this is the part that sometimes confuses folks, and I get confused with it as well. So normally what you would do is you would use this identifier here, 2930, as your global, and then you use your Confederation ID, your global ASN. So I'm going to go ahead and do that, and then Confederation peers, and then the IP and then who you're going to peer to, and that's going to be 1920, right? So if we do show run pipe section BGP, it's going to look something like this. And then I'm going to type in no BGP default IPv4. So we're going to have to activate our neighbors. So what I'm going to do is type in a neighbor of, so it'll be 3.0.0.30 remote AS of 2930. So it cannot configure the local peer. Oh, that's right. I'm on, I didn't realize, I thought I was on 29. We'll do 29. 29 remote AS there, and then we're going to say update sources loopback 0, then address family IPv4 unicast, and then we're going to activate the peering like so. And then we're going to go over to 29, do the exact same thing. Router BGP 3, BGP Confederation identifier 2930, and then we're going to do Confederation peers, and the peers ASN is going to be 1920. We're going to say neighbor of 3.0.0.30, remote AS of 2930, update source loopback 0, address family IPv4 unicast, and activate the peering. Now that's going to give us an iBGP Confederation peering underneath the address family. So we'll wait for that to come online. Let's see here. Do show run pipe section BGP. Actually, so 30 isn't coming online either, and I turned the, oh, let me turn this off globally. No BGP default IPv4. Do show run pipe section BGP. So this is where I think I might have it backwards. 2930 and the ASN. And we'll do BGP Confederation peers 2930. Throw that in there as well. I can't remember if that's actually required or not. It's been a minute since I've done confederations. BGP Confederation peers 2930. I don't know if that's necessary or not. Do show IP route OSPF. So I should have the peering. Okay, I should have reachability. So do ping 3.0.0.29 sourcing from loopback 0. I can ping, and what I'm going to do is, in this particular case, show BGP IPv4 unicast summary, and it's an idle. Show run pipe section BGP. I activated it. So why is it not? So this particular example, what we'll do, since we're stuck, so we're in a situation where we don't remember how to configure it. I'm going to come back over here to the iOS configuration, and then I'm going to go. This is iOS, and actually this is Nexus OS. I'm going to take a step back to iOS configuration. So this will be iOS XE3S, and I'll look at the documentation, configuration, and then I will look at configuration guides, and I'll come down here to where we do IP routing. I'll look at BGP. It's older config, but it's still going to work the same way. So we're going to come down, we're going to look for confederations. I'm not sure, but it'll be something where I have to confed. Okay, we're going to look at, let's see, what are our options here? Confederations don't show up in the outputs here, so that means I'm going to have to go to configure basic BGP4, and I'll do chapter contents. So let's see here, there's nothing specific to that. So if I do a book level confederation, it doesn't have anything specific to that match. I know confederations are possible. Let me see here. Let me go back a step here to this. I don't think this would be it either. This is multi-homing. Yeah, that's not what I'm looking for either. Well, we'll talk about, this is something we could talk about when it comes to how to multi-home, which we will be doing later on. Let's see here. Where is the... It's been a minute since I have done that configuration. So I'm going to cheat a little bit, and I'm going to go Google for iOS-XE BGP Confederation. So this one says it's in there. Configuring internal. Here we, okay, so it's internal BGP features. Let's see, internal. Is that an option here? Internal BGP features. Okay. That's where it's knowing where to look is important. Configuring a routing domain confederation. So, and if we look at the top here, we're going to look at configuration example configs right here. So the global, let's see, the way it's saying here is the BGP speaker, ASN 6001, the BGP Confederation peers. So is there a topology? So essentially, I think I have it backwards. So we have, this is the global AS. These are the confederation. I think I've got it backwards. I think that's what the problem is. And then we're going to peer to 6002 and 6003, which is what we're going to do. That's why we have those peering set up. And then, but this is going to be our global. So, okay, so the confederation consists of 3 internal autonomous system numbers, 6001, 6002, and 6003. The BGP speakers outside the confederation looks like a normal ASN autonomous system with the ASN 500 specified. Okay, that's okay. I have it backwards. So let me go ahead and just adjust that config. It's a pretty easy manipulation, and I honestly could not remember. So if I go back to global config and do show run pipe section BGP, I'm going to say no router BGP 3. And so what we're going to do is router BGP, in this case here it's going to be 2930, and then we'll type in no BGP default IPv4. Then we'll type in BGP confederation identifier is going to be 3, and our peers are going to be 1920 and 2930. Oh, 2930. Beg your pardon? Local member, yeah, not allowed. Okay, so do show run pipe section BGP. Oh, that's right. So that's because we're not going to peer. So 1920, we're only peering to one other ASN. So that's what we're going to do. And we're going to do here is we're going to type in neighbor of 3.0.0.30 remote AS, and we're going to say in this case here would be 2930. The update source be loopback 0, address family IPv4 unicast. We're going to take this and activate it, and we're going to do the exact same thing on 30. So I'll take this global config, no router BGP 3. We'll type in router BGP 2930. Type in no BGP default IPv4, BGP confederation identifier of 3, BGP confederation peers of 1920, and then neighbor of 3.0.0.29, remote AS of 2930, update source loopback 0, address family IPv4, activate the peering. So now we should get a BGP peering between 29 and 30 here momentarily. There it goes. And that was what I was expecting. So now what I'll do is I'll do the exact same thing on XR. So on XR, we're going to take the same logic. So on XR 19 and 20, which is way over here, log into them. Router BGP, in this case here, we're going to use 1920. We're going to do BGP confederation, and it's going to be identifier is 3, and the peers is going to be 2930. Then we're going to type in neighbor of 3.0.0.20, remote AS of 2930. Update source is loopback 0. Address family IPv4 unicast. And then we're going to do the same and show config. We're going to go ahead and commit that. And then on 20, we'll do the same thing. Router BGP 1920. BGP confederation identifier is going to be 3. Confederation BGP confederation peers 2930. Neighbor of 3.0.0.19, remote AS of 1920, update dash source loopback 0, address family IPv4 unicast. And then we're going to go do a commit. So these will be iBGP peers instead of a confederation. Show config failed. Oh, okay. Address family IPv4 unicast. So you're supposed to create the address family before you commit the config. Let's see if I remember to do that on 19. Yep, and I didn't. So if we show configuration, you can see that there's no address family yet. So address family IPv4 unicast. And if you do a show config now, the address family has been created, and then we're going to be able to commit it. And momentarily, we should have a BGP peering between the two. Give that a moment to do its thing. So do show BGP IPv4 unicast summary. Not sure why it's not coming online. Do show run BGP. Do show run router BGP. Okay, so I have the two configurations there. Not sure why it's not forming. So this is where you go back to here, take a step back, and we look at iOS 6E3S. You take a iOS and NXOS, and then you come down here and you look at iOS XR. And we're going to look at configuration guides. And so let's look at all the releases. And I'm going to go to an older release. Go to the oldest Nexus ASR one I can find. Let's go 7.0. And we're going to be looking at routing configuration guide. And we'll look at BGP, because they're one main book for BGP. Expand this out, and then we're going to look for, we'll do a quick search for Confederation. So the way that it does the config is it will tell you what the capability is, how the route reflector, or how it works, but you have to go down to the examples down at the bottom with this documentation configuring routing domain, how to implement. So it's saying confederations AS number, confederation identifier. This is going to be the global one, and then you have your peers, and sometimes they'll give you an actual syntactical breakdown here at the bottom. Let's see if it'll go down towards the bottom. Okay. Okay, so here we have the identifier is 666, the confederation peer 6002. Okay, so I'm not seeing anything spectacular about the configuration that I'm doing. So the config looks the same. If we verify that against what we're seeing here, confederation identifier 3, confederation peers, all that looks correct. The only thing I'm doing is an update source loopback 0. And then I'm doing the config. So let's do show IP route. I do have 19 in my routing table. So if I do ping 3.0.0.19 sourcing from loopback 0, I can ping. So it's not a reachability issue. So what is... The only time you ever have to do this route policy thing is when you're doing external connections. And this right here, in this particular example, this would be an external connection because it's going outside of, it's not a confederation peering because it's got 6001 and 6003. So this would be an iBGP peering because it's inside the same AS. This one and this one are external Confederation eBGP peerings, and this would be an external global AS peering, and that's, you can do the route policy to at the address family level here. So everything looks correct. Not sure why that's not behaving. So okay. Let me go back over here and let's take a look at why this is not working the way we want it to. So sometimes it's gonna, I'm not sure how much more time I want to spend on this. So show BGP IPv4 unicast summary, and it's at idle. I'm trying to think if there's anything else that I need to configure for the confederation. Let me go ahead and try to set up a peering out between 20 and 30. So router BGP 1920 do show run router BGP. 1920, 1920, 2930, AS is 3. Address payment IPv4. All that looks right. 19 do show run router BGP. 29. Oh, that's why. I didn't even notice that. I meant to type in here. That's why. This remote AS of 1920. Update source. Loopback 0. Address family IPv4 unicast. Commit. So I had the wrong ASN. My fault. Verifying the config is important, right? So, and there it goes. So do show BGP IPv4 unicast summary. And now I have an active peering. So from 19 to 29, let's back this up a little bit. We'll do a neighbor of 3.0.0.29, remote AS of, this is going to be the other peering. This is going to be 2930. Update dash source is going to be loopback 0. Address family IPv4 unicast. And commit. And let's go over to 29. Router BGP 2930. Neighbor of 1920 or 3.0.0.19. Remote AS of 1920. Update source loopback 0. Address family IPv4 unicast. And then we're gonna activate the peering. Give that a couple seconds to do its thing, and we should get it peering between the two, hopefully here momentarily. Do ping 3.0.0.29 source loopback 0. So it's definitely not a reachability issue. Do show run router BGP. My Confederation peers 2930, which is what I want to see. Okay, so do show BGP IPv4 unicast summary. That's sitting at idle. 19 do show run pipe section BGP. Oh, no, that's right. So 29 to 30, XRB to 19. Okay, so that should be okay. Not sure why that's not working. Let me do a let's see, why would that not be working? You know, I might not be able to do loopback to loopback here. I may have to do direct interface peering. Let's try that instead. So on XRB 19, do show run pipe section or router BGP, and let's say no this IP. What we'll do instead is we'll do a neighbor of, because okay, I know what the problem was with that config, iBGP multi-hop. So that would explain it, because it's not iBGP. You need to do remove the disable connected check or put an iBGP multi-hop. So actually, let me go back to that here real quick, and let me put this back in with all these commands, right? But what I need to do here is type in iBGP multi-hop. We'll say 2. Commit that, and then we'll do it on CSR29. I'll type in neighbor of 3.0.0.19 iBGP multi-hop, and we'll say 2. So that should fix that problem. And there it goes. And that's okay. That proves it. So I'm going loop back to loop back. You can do loop back to loop back, and it's something I forgot about. Normally I don't have to do this. I do a lot of internal. I do iBGP, but on directly connected attached hops. I'm not doing loop back to loop back. I might do SVI to SVI, but it's still directly connected. So, or sub interface every once in a while. So that's where that comes into play. Now this other one here, I'll do point to point to show you the difference. The only difference is we're going to be using this directly connected 3.20.30 subnet to peer, just like we did with OSPF. That's the only difference. So on 20, we're going to go ahead and we got a peering to 19. That's okay. That's good. So we're going to do a neighbor of 3.20.30.30, remote AS of 2930, and then we're going to do address family IPv4 unicast. So it's going to be directly attached in this case here. And then on 30, we'll do the exact same thing. Router BGP 2930, neighbor of 3.20.30.20, remote AS of 1920, address family IPv4 unicast, activate the peering. And so after just a moment or so, we should be good to go with the way we get connectivity up. There we go. So if I do a show BGP IPv4 unicast summary, I have that squared away. Okay, so now let me take just a minute and explain why I chose to do things the way I did it. So with these guys being iBGP and these guys being eBGP, or right here. So we're going to have iBGP between the CSRs and XR boxes, and then eBGP between XR and CSR. The reason why I'm doing it that way is because they're, the devices themselves, the iBGP peers, will always be learning routes from each other via eBGP peers. So 20 is going to be eBGP to these two, 19 is going to be eBGP to 28. Same thing with 30 will eBGP out to 33 and 35. 29 will be eBGP to XR18. So because of that, since they're directly connected and they are iBGP, they'll automatically propagate to each other. So it's a full mesh, even though it's a direct point-to-point between two routers. So BGP forwarding operations will work as is. If I was to do iBGP here as well, we'd have to do full mesh. I don't want to do full mesh. So by having these guys as eBGP peerings, they'll treat each other as two different autonomous systems, and therefore they'll follow eBGP forwarding rules, which means if I get a route in, these guys see each other as iBGP, these guys see each other as eBGP. So any routes this guy learns, any routes XR18 advertises to 29, 29 will advertise to 19. And it'll be an eBGP, the next hop will be 29, and there, so on and so forth. So we might have a small issue with the loopback addresses, but I'll come to that at a different point in time. So as you can see, that's basically how that would work. Now the caveat here is when we actually start advertising routes, you'll see some interesting outputs in the actual AS path. And if I remember correctly, and it's been a while since I've done this, because normally, like I said, unless I'm labbing it out, I don't ever use confederations. I do a confederation just because of the fact that it adds a twist that I don't see a lot of people using, and I like to try to keep my knowledge and capabilities as up to par as I can. So what that basically does, when you have this connectivity set up the way we do, when you've got a confederation deployment, and I forgot where I was going with that. The connectivity, since it'll be treated like a eBGP peer, we won't have to deal with any of the iBGP forwarding rules. I believe the ASN we'll see is going to be 23456. If I'm not, actually no, that's AS dot. We'll see in connectivity between the devices, and I forget which ones we'll see. we'll see the connections come through, and there'll be you'll see the actual Confederation AS inside the Confederation. From the outside world, from CSR 32 or from CSR 28 or XR 18, all we're going to see is AS 3. That's all we're going to see, because that's the global AS, and not only the Confederations will see each other as Confederations. So I think it'll be iBGP is where we're going to learn them, or it might be between the iBGP peerings, but I honestly don't remember. But the bottom line now that we have all this set up is, in the next video, we're going to go ahead and start getting a bunch of iBGP peerings online. So we're going to do a bunch of iBGP to get it all squared away the way we need it to, in order to start getting route propagation to work the way we want it. So, and then one of these devices here we're going to have to set up as loopback address will be quad 8. So we'll have something to telnet to. I'm probably going to do it at 28, just because of the fact that it's a CSR box, and it'll be really easy to create a loopback, and then I'll be able to ping that and do some failover testing. But I'm going to go spend the next video, we're going to go through and get all of the iBGP peerings up. It's going to be a lot of repetitive config, and get all the inter-ISP routing done. That'll be the first thing that I do. Get that done, and then as routes come online and BGP has time to propagate it, it'll take a couple of minutes, but eventually you start seeing routes showing up everywhere you need it to. And then I don't have any optimization necessarily built into the lab guide, or to the lab tasks that I've currently got built. But for example, most customer devices don't need a full BGP table. They'll need just a default route. So a lot of times what we'll do is we'll say default information originate on, say, XR17 down to CSR 31, but then we'll put a prefix list out to deny anything but the prefix the default route. So we won't want to advertise a bunch of routes down to CSR 31, so that because what potentially could end up happening is AS 65001, if it learns too many routes, could potentially become transit for the rest of the internet. In the event that a bunch of you've got two legs going out to the internet, two different service providers that you're peer to, and CSR 31 is a great example because it's got two ISPs it appears to. Well, I'm sorry. Yes, it's got two ISPs it appears to. So it's dual homed. So actually, I'm sorry. It's multi-homed. Dual homing is you're peering to the same service provider twice. Multi-homing is you're peering to two different service providers. So in that particular case, if I'm learning a bunch of routes from 17 and from 74, there's the possibility to where something happened to this link right here between ISP1 and ISP2, that the best route could be through AS 65001. And as long as if the routes are learned improperly, that could be a problem. And there's some BGP communities we can throw in there with like no export, no advertise, stuff like that. And you can do some configuration specific to subconfeds, where you can do don't advertise a route outside of the Confederation AS. So it won't be able to leave this AS, stuff like that. We're not going to get into that in this section of videos, only because of the fact that the lab isn't going to be built for it like that. So what I'm going to end up doing is going through and setting up the connectivity so that in the event that there is a problem with it, that there won't be a problem, because the lab isn't going to really require us to do that. I'm probably just going to do a default information originate and a prefix list out that says, hey, only allow a default. So like IP prefix list permit 0.0.0.0/32, because it's just that specific route, and then do a deny everything else, and put that outbound so that CSR 31 would only receive a default route, stuff like that. So, but we'll come to that at a later point in time. With that being said, that is pretty much everything I wanted to cover in this video. So in the next video, we're going to set up a handful of iBGP peerings. We've got 1, 2, 3, 4 of them to do inter-service provider, and then we're going to have we're going to have, what's it going to be? I'm going to have 1, 2, 3, 4, or I'm sorry, I'll have to look back at my lab guide, but it's going to be like 6 or 7 or 8. It's not going to be a ton of them. And you got to remember, anything that's going down to the MPLS provider isn't going to get touched right now. We'll cover MPLS, we'll get that working in a separate set of videos, and then once that's done, then we'll work on getting the colo brought up. But for right now, we're in good shape. So with that being said, thanks so much for stopping by, everybody, and I'll catch all of you guys in the following video.